Hi, everyone. Today, we're going to see how to use the VisualARQ components inside Grasshopper. Okay, so basically how to use all these objects and some other functions directly in the Grasshopper environment. But first, I would like to make a short introduction about what is VisualARQ, what are the main features in order to understand how we can use it directly in Grasshopper. So basically, as you may know, VisualARQ provides a set of architectural objects. They are parametric, and we can edit them through parameters from the properties panel. They have some associations. We can insert doors or windows inside walls or curtain walls. And we also have a double representation of them in 3D and also in plan view. All right. But let's talk about a little bit the hierarchy of these objects in order to understand how they are connected and the possibilities of them when it comes to edit them. So first of all, we will talk about object types. Okay, that means walls, curtain walls, columns, beams, stairs, and so on. So inside each object type, we get a list of styles that determine the features of this object type. For example, here we can see different door styles, and each style determines the opening profile, the opening type, the number of leaves, okay, the dimensions of these leaves, the dimensions of the components of this door. All right. Also the materials, the attributes. So basically, the styles define the features of the objects, and we can edit them. So all the objects with the same style will change. Later on, we can talk about sizes, and this is something that only a few object types have. For example, doors, windows, openings, beams, and columns have sizes within a style. And well, we can have, in that example, a door using the same style, but with different sizes. All right. And finally, we'll be talking about instances. So basically, what the geometry we have in the model. Okay. In this case, some doors that may be using or not same style, or same or different dimensions. Okay. So just following with this concept, we've got here the dialog in Rhino where we can edit the wall styles. For example, in case of walls, the styles determine the number of components, in this case, wall layers, the thickness of each component, all the wrapping settings, and other attributes such as all the material, the color, and so on. But later on in the model, we can have different walls using the same style, but with different dimensions. For example, in this case, we've got here three segments of wall with the same style, but with different heights. Okay, so there are parameters that can be edited by style that will affect all objects, but there are some other parameters that can be overwritten by instance. Okay, like the height of the wall, or in case of these windows, the dimensions of the windows. All right. So we'll be talking about some properties that objects have that are calculated automatically, such as the volume, the area, the length, okay, that they vary if we change the dimensions of this object. But on the other hand, we could talk about static dimensions, static parameters. So basically, they are values of parameters that we can add to the object, and not only to VisualARQ objects, but also to Rhino geometry, and they are static. Okay, if we change the geometry, they stay. And well, in Grasshopper, we will be able to read and also manage these values using specific components. It's important to understand how each object is generated, okay, which is the input geometry that each object requires according to the object type. For example, in case of walls, curtain walls, beams, railings, and also stairs, they require a path curve, all right? While for roofs and slabs, they require a boundary curve or a surface. In the case of doors, windows, or openings, they require an insert point and alternatively a host object, which could be a wall or a curtain wall. And then we've got the element, furniture, columns, or annotation objects. They require an insert point, and that's it. In future versions, we will expand these possibilities, and make, for example, a furniture be created from a path curve. Why not? But this will come in the future. Then we've got the spaces that can be created from different kind of geometry as inputs. The sections require just a line, And section views require a line, section, and a point, and plan views a point and also a level as a reference. Then we've got also tags and tables, which are objects that are not available in Grasshopper. It's important to understand that the limitations we've got for these VisualARQ objects in Rhino are the same in Grasshopper. Okay, for example, we cannot create a wall from a freeform curve, not in Rhino, and we won't be able to use that curve to create a wall in Grasshopper. Well, this scheme shows an example of how the VisualARQ components work. So there are some components to create objects, all right? For example, for this wall. Then we've got other components to create styles. So that means the main component and all the components to create the subcomponents of the object, in this case, wall layers. And then we've got components to deconstruct objects. Okay, that means objects that we can obtain the path curve of a wall or the style name, alignment, the height, these details. And of course, we've got other components to deconstruct the style. As you can notice, we've got here this kind of well, components that are kind of the opposite, right? So here, all on the left side, all the components to create, and on the right, the components to deconstruct and obtain the similar information. From the website, there are some learning resources. Okay, you can check eventually, and some simple exercises to get started if you want. It's all available in the website. And today I will show a few examples. Okay, very basic stuff, but I will start with a very basic workflow. Okay, to use these VisualARQ components. We will follow with this typical exercise to create this domino structure. Okay, and then we'll see also how to manage data on this exercise as well. And if there is time, we will see a few more examples. Okay. All right. So, well, here you always have the mail support, my personal support, and also for the VisualARQ. Later on, we can also maybe make some round for questions. So let's jump to the Rhino. All right. And okay, I'm gonna delete this. So first of all, I will open Grasshopper. And well, if you have VisualARQ installed, you will notice here that we've got some different components than when VisualARQ is not installed. So we can find here all the params, okay, to reference VisualARQ objects. Okay, we have a component for each object type, but we also have this object component that is used for any VisualARQ object. Then we've got some params to reference styles, okay, and also some additional architectural inputs to edit VisualARQ objects or styles when we create the definitions. But the main VisualARQ components are under this main ribbon. Okay, we can find all the objects to create the VisualARQ, all the components to create VisualARQ objects. But in addition, we've got also components to work with levels, profiles, and here we can find a mixture of components to work with data, with parameters or properties. There are also components to work with blocks, okay, that they are useful in some cases to create, for example, furniture from blocks or windows from blocks, and some other tools for creating hatches, texts, all right, or these components to do Boolean operations with VisualARQ objects and Rhino solids. All right, we will start with a very basic example. So I'm gonna drop here a wall component, and we can see that we've got like a standard wall. It takes a default path and default dimension, default style, and well, I mean, we can just draw here a curve. I'm gonna reference this curve here with a curve component. Do right click, set one curve, and select it. So now we get this curve linked. And this will be the path curve of my wall. So I connect this here, and now I've got this wall attached to that curve. All right. Well, but if we want to add more detail to this wall, we will need a wall options component. So basically, we find here when we connect that to the wall options input, the parameters that we can find in a VisualARQ wall. Okay, basically the object parameters that we can edit by instance. And for example, we can change here the height. So I'm gonna place a value from 1 to 10 to change the height, for example. All right. And well, if we bake this this wall, it will become a VisualARQ wall, of course. But here we can also create a wall style. So for this case, we will need this wall style component. And well, before creating a style, I mean, let's reference one. Okay, so I'm gonna go to params. I will use one of these wall style components. And here we can either do right click and set one wall style, or connect this here. Of course, now the style information is missing. Do right click and set one style from this button. All right, so I just noticed here that I have just one default style. And this happens because I started this document from a random template. If you start a new document, so I'm gonna open from a VisualARQ template, we'll see that we've got here the full list of styles. So I'm gonna draw the curve again. Okay, so I'm gonna reference it one more time. And now I can do right click on this component, and you will see that we get a list of all the document styles. So we select the desired one, for example, this one. And now we've got this, well, this style. But let's create a new one. Okay, so we have this component for that. We can connect this here. So now there is a style information missing. I'm gonna call this this style. Let's call this new. I know it's very original name. And for components, we will need wall layers. So we go to the VisualARQ wall, and here we can find the wall layer component. Of course, for each object type, for example, in curtain walls, we can find more components, okay, since each object style has different kinds of components. So I'm going to connect this here. And of course, with a numeric slider, we can change the thickness of this layer. All right. If we want to have a multiple layer style, we can just copy this component multiple times. We connect this in addition to the other components, and we've got here the different thicknesses for each layer. Okay. Or another way to do this is by having a list of thicknesses. So this would be the same, and from here it will come out 3 wall layers. Okay. All right. If we bake this this wall now, you will notice that, I mean, when we select this object, I'm going to hide this. So not only the object, but also the style has been baked. And maybe here it's important to mention that if we do any change on this wall style information, maybe let's remove this and convert it into one layer wall style again. If we bake now the object, okay, the style information is still in the document, was baked before. And here I only bake the geometry, but not the style properties, which are taken from what this VisualARQ reads in that document. If we want to override the style with the new features, we need to bake the style component. When we bake this, now that wall that is using this style takes the new features, okay, according to what we have defined here. All right, so let's go on. Now I'm gonna insert a door. So the principle is the same. We have this component that requires a position. So I'm gonna do right click here to reference one point somewhere here. And of course, the door is placed in that position. But as soon as I tell this wall to become to be the host of this door, that door just snaps onto the closest point along the wall path. Okay, so if we change this position to another one, okay, we can see that the door moves to the new position. As a position, of course, we can define multiple points. For example, we can have like a point on curve, point on curve. There we go, and select one of the points of this curve, okay, to be the position of the door, right? But imagine that if we didn't have created that wall in Grasshopper, maybe we wouldn't have this curve. So we could use a deconstruct wall component instead, okay, to get basically the same path curve. So we can either now connect this point on curve on the original curve or onto this one that we can read from this wall or any referenced wall. This might be useful in many situations. But as I was mentioning, if we want to create, for example, an array of doors here, we would use the divide curve component. So I'm gonna divide this curve. Okay, let's say from using points that go from 1 to 10, and use these points as the position of the doors. All right, so I'm gonna just put more doors here, and you see how they distribute along the wall path. Of course, I don't want to draw this first and last door. I mean, if we check this list of points, we need to, let's say, remove the first and the last item. The first item corresponds to the 0 index, and the last one corresponds to this value here. So therefore, we can just put here the 0 index. I'm gonna use the cool index component. Okay, so here I connect all this list of points, and the number 0 will be the first index to call, and the second one will be this number that comes out from here. Now we can connect this list of points as the position of the doors. Okay, so we can play with the array of doors in here. Now, again, with these these doors just took a standard dimension, standard style. If we want to change these details, we need a door options component. So that's what I'm gonna use now. We connect it here, and here now we can define, for example, the aperture. So with just a numeric slider, I can connect this to this input and change the aperture of all these doors. Or we can define one style. Here I'm just gonna do right click, set one door style, and maybe select, well, maybe this hinged glass. And finally, I can edit the profile. So for this purpose, we've got a series of components to define profiles that can be used for not only for doors, but also for structural profiles. And in this case, I'm going to use a rectangular profile. It's important to be aware that we need to use a profile that matches with the profile linked to the style I'm using. Okay, so just an example. If we use here a circular profile, this is not going to work. Okay, because this style I'm using has a rectangular profile. So it's important to take that into account. And finally, I will define here some dimensions for the, let's say, for the width and the height of this profile. Okay. So this would be the width, and this would be the height of these doors. All right. Well, there is one exception in which a door style can take a profile that is not the one that has assigned, which is the option to use a custom profile. So in this case, this is a component that converts any curve into a valid profile for a door. So if I draw now a curve with any shape, okay, let's imagine a kind of uncommon situation, okay, uncommon profile. I'm gonna reference this. I do right click on that curve, and connect it here. This component can be used especially also for custom profiles on beams. It can also include voids. And now I can use this profile for my door profile. Okay, and this what I get. And of course, if we extend this is gonna update that those doors. Okay. All right. So now, if we make these doors and the wall, as a result, we'll get doors and walls. Okay. I can move this to another place just to check it out. So we can see this is a door, and this is a wall that we can further edit. Okay. Great. Let's move to the next exercise. I'm gonna just open a new document. I'm just gonna remove this, and I'm gonna construct this structural system, or the domino structure, based on of course, Le Corbusier's design. But here I'm gonna use a rectangular grid first to define the grid of points that will be used to place columns. So I'm gonna define so I'm gonna use the bifocals this time. And I will define the extend X as a value that goes from 1 to, let's say, 10. Or yeah, 10 would be fine. And same for the extend in Y direction. All right. And I'm going to do, same for the size of the cells. So we'll define the minimum size of 3 meters and to, let's say, a value of 10. 10 would be maybe too much, but anyway. And I will use this, I copy and paste it for the other direction. Okay, so now we've got this grid of cells. And well, the first thing I will do is to find the boundary of the cells. I'm gonna use, there are different methods to obtain that, but I'm gonna use this region union. So I'm gonna plug these cells here. And here I notice that I've created 4 boundaries. Okay, that happens because these cells are grouped in four groups. So the data structure that comes out here are four groups of cells. Okay, so what we need to do is basically flatten this so it becomes to one group, and then we've got one single boundary, and we are ready to use the slab component that will take this curve as input geometry to create that object. Well, since we are going to place here some columns at the intersections of these points, at the grid points, we need to have the slab a little bit wider than this structure, this grid dimension. So I'm going to use an offset curve offset component to just use the offsetted curve instead. Okay. And of course, with the parameter, we could control the distance. But 1 meter, I think it's the default value. It's fine. Now, let's insert the columns here. So again, we use a column component. The points, the position will be these points that come out from the grid, from the rectangular grid. And if we want to change the dimensions of these columns, again, we need a columns option component that we will connect in here. Now we can reference one style. So I can use this column style. Here it is, component, do right click. This will search for the profiles available, styles available in the document. So I'm gonna select a round one, connect it here. And now using a proper circular profile component, I will be able to define the size of these columns. Okay, I can control the radius very quickly from here. Well, I just need to define the height, but this is something that I will do it in a second. First, I would like to start copying these slabs and columns upwards in order to define the stories. So first of all, I will create a slider that will define the dimension of the story. Okay, that will go from 2 meters to let's say 5 meters, for example. And I'm gonna call this level height. Okay, and also I need another slider that to define the amount of levels, number of levels. This would go from 1 to let's say 20 stories, and I'm gonna call this number of levels. All right, so I just need to move this this slab. I'm going to use a move component, and I will use the well, this dimension. I'm going to define a z component, a z vector, to define the motion. I mean the level height. Okay, but this gives, of course, just one level, one height of the height of one level only. If I want to have several levels, I will need a series of values. Okay, that will start from 0, will take the step as the level height, and the count as the number of levels. Okay, so here what I will get is a list of vectors that this slab will move upwards. Okay. Now, just notice that the columns don't reach the well, the slab surface, and we can use now this level height to connect it here. Okay, but what happens? This is actually going through the slab, and maybe I want the columns to end at the bottom of the slab. So then I need to figure out the thickness of this slab and subtract it from this level height. And there are different ways by which we can obtain this thickness. Maybe the quickest one is from the generics. We've got here this component that reads the thickness of any VisualARQ object. Okay, but alternatively, I could use this get property component. Okay, which asks me for an object and a property. There is another component that shows a list of properties. It's this property name. I should look for the thickness one, and I connect this here, and will return any value. I mean, this is useful for when we need to read any of these, data from the object properties. So, well, we've got now this component. I'm gonna move these columns a little bit further here, because now I will need to subtract from the height of the level this value that we've got here. Okay, and this will give me the proper height of the columns. All right, so now we just need to move these columns upwards in the similar way as we have done with the slabs. And I'm going to use a new move component. Okay, the z value could be the same. Actually, this could be pretty much the same. And the geometry would be these columns over here. All right. And now I noticed that, well, the columns didn't copy it as I expected. Or maybe yes, because remember that in the original grid of points, that this what it has with the columns have inherited. So we had this data structure that is grouping, the points or cells by columns and rows. So what we need to do, I mean, if we take a look at what it comes out from this column list, it's groups of columns. Okay, and what we've got here are, I mean, one single group of vectors. So we need to convert all this group of columns into individual groups. So each group just moves all these vectors that we have assigned. So I'm going to graph this. We have individual columns now, and all them just move upwards according to this list of vectors. All right. And I just noticed here that there is one slab missing. So I'm going to use the slab. So I will need to add one more number here. So I'm going to add one value. Okay, so there is one more slab that goes up. All right, so you have seen how quickly and easy to create this domino structure. Of course, here we can play a little bit with this parameter to check the results. Okay, we can change this the size in one direction or another, and also we can maybe change the level height. Okay, to see a little bit to play with the results. There are hundreds of more stuff we could do to develop this further. Maybe I can just show very quickly. Let's show this in wireframe, how we can create maybe a subtraction. Okay, imagine we have a kind of opening, okay, for this, for the elevator, or for a staircase, whatever, in that shape. So we could just reference this curve, all right, and connect it to a slab subtract component. So then we've got here all the slabs. I connect this curve. I'm gonna hide this, and we'll get these well, these holes in all the slabs. All right. Okay, so let's take a look at the final part of this session. I'm gonna now work with data on geometry. We'll take the columns. Okay, I'm gonna use a column component here to connect all these columns. Okay, I'm gonna just forget about this by now. And the first thing I will do is to name these columns. And I will name them by, well, by a list of names that, of course, that depend on the number of all the grid structure, obviously. And for that, we'll need first to use a set component, set property component. Okay, this is a component that takes an object, uses a property that could be the name. Okay, so I have already the name selected, and also uses a value. So here I just need to use a concatenate component to get a list of names. Maybe I can just use this string call from column, and a list of numbers that goes from 1 to the number of columns we've got. Okay, if we take a look at what comes out here, we can see this is still, you know, grouped in different groups. So I'm gonna just flatten this. Okay, and now I will use a list length component to know the number of columns that I've got here, 72. All right, so now I just need to create a series of numbers. So it will start from 0. The count will be 1, and this would be the total number of columns. And I just need to connect. Maybe I will just move this here. I connect this to the fragment B, and as a result, I will get this list of names. And this is what I need to connect to the values. Okay, there is a warning message here. Let's check it out. So the number of values must be the same as the properties. That means that we need to graph at least this, but in order that we ensure that all the data that comes in has the same structure, we're gonna graph the 3 inputs in here. All right. So what we've got here is some columns with the corresponding numbers. If we want to add a new parameter, for example, we could add one of the document parameters. So when we insert a column, for example, this one, we've got here the list of custom parameters that are created by document, okay, including cost, material, or finish. So we can read these parameters using these document parameters. Okay, we can get a list here of these parameters. So I'm gonna use the first one, the item cost. It's the first one in this list. Okay, and this will be the parameter that I will assign here. So I'm gonna just copy this. So the objects is what it comes out from here. The property is this one, and the value can be any number, or maybe imagine, well, here I'm just setting a fixed number, but imagine that this is a number calculated according to the length of the object, the volume, so we could obtain this value by multiplying it to any property of the object. So this will be the result. I have this already graphed. So now when I pick these columns, okay, I'm gonna make also the slabs. What I've got here is a column that has this cost, okay, value, and also the name, the corresponding name, as I have given. So in this case, VisualARQ components can be used to name to provide data to the existing geometry. And now let's imagine the current situation, the next situation in which we would like to change the name of these columns. Of course, you don't want to do this one by one. And the problem of, let's say, for example, we want to call this, just change it by C. Okay. The problem is that if we bake this component, now we'll get duplicated columns, right? But there is a magic component here, which is called update property, that if we reference all these columns that we have got here, I mean, we can use, in this case, this component, or maybe easier, the VisualARQ pipeline, to just double click on the column and reference all these columns. Okay, we can, well, connect this value, okay, the new values that we have created. We just need to set here the name, the property name. And again, we need to graph this to ensure that everything will work fine. And click on this button. Now, when we close, we can check that these columns just took the new name. So it's a very easy way to overwrite static data on existing geometry without having to, well, they need to get duplicated objects and manage it with layers in order to, you know, delete them. All right, so the final time is approaching. So I think I have time just for one more example. I'm going to show very quickly, well, just a definition, a simple definition that I created, but it could be very, very useful to create, for example, automatic sections and elevations of this of any model. All right, so this would work with any model, and you see that definition is not so complex. Actually, this is available in Food for Rhino, this definition, if you want to check it out. And basically, it reads all the B-reps, meshes, and visual objects using pipelines. I make a bounding box in order to obtain, you know, the 4 edges of the bottom of this bounding box, which I use to generate these section lines and also 2 cross sections. And finally, I've got, I calculate the insert points of my section views. So at the end of this definition, I've got this section view and section line components, either for the elevations as for the section cross sections, that when we bake them, as a result, we obtain the automatic views to the views of this drawing, of this model. Okay, so there we go. And of course, this takes all the section attributes that we have assigned previously to the geometry. And as the last example, I want to show you, very, very easy one. I'm going to work from the top viewport. Okay, I'm going to enable the ground floor. And I will show you a very quick way to generate the, I'm going to delete this piece of wall, to create the dimensions of a room. So if imagine that we create here a space. Okay, a space is an object that detects the surrounding walls. And now I'm going to reference this space in Grasshopper. So I go to VisualARQ, no, I go to params, objects, space. So I'm going to reference this one. And now I'm going to deconstruct it. So I will obtain, in this case, the curves, okay, the boundary curve. So if I explode this curve, I will obtain the different segments. And just with the endpoints of these segments, I can generate dimensions. So I go here to display, aligned dimensions, and this requires upon A, upon B. Okay, maybe the offset is something that I can start from -1 to 1. Okay. All right. I think this is how I want it to go. The preview is very big. Maybe I can also choose a smaller value for the preview. Okay, I'm gonna show this in Wireframe. But anyway, when I bake these objects, they will take the current annotation dimension style. So when I bake these dimensions, I get automatically all the dimensions of this room. Okay, so well, this is all I wanted to show you for today. There are, of course, hundreds of more possibilities to work with, and I hope you have enjoyed. Maybe we have some time for questions now. So maybe you can ask for permission to talk if you have any question. Yeah, by the way, I'm recording this session, so I'm gonna share with all you who registered, but also I'm gonna upload it to the VisualARQ channel in YouTube. Okay. All right. Gabriel is asking, is there any workaround to bake a style or an object with all the attributes, such as materials, patterns, layer, etc.? Well, unfortunately, this is not ready. This is not possible right now. I mean, everything that is related to the attributes, such as the section attributes, materials, colors, this is something that is not available from Grasshopper now. But we have had some requests about that, and we may add this feature in the future. All right. And Mikel is asking about relation with SubD. We haven't explored that so much, but I mean, visual objects can be created from SubD in Rhino, so they should work with SubD components in Grasshopper. Okay, if you experience any problem, just please report it, but it should work fine. All right, yeah, if you want the PowerPoint presentation, I mean, at the beginning or any of the files I've used today, please send me an email. I'm gonna just show this back, and I will be happy to share it with you. Okay, so yeah, just send me an email to here will be the easiest way to get all these files. There is one more question about the spaces. Alun is asking me, is it possible to work with the spaces before we have walls? Well, yeah, it is. Actually, you can create spaces from curves, okay? And you just need, when you create a space, we just need that, that geometry. Could be a curve, could be a surface, okay? So you don't need to have walls, all right? Yeah, of course. All right, so any more questions, please? All right, so I will leave it here. I thank you all for your attention. And yeah, feel free to keep in touch for any suggestion, any request, or any doubt. All right. Thank you so much. See you soon.